I'm going to give you some more practice problems with the chain rule today. So I'm going to start out with just this first example, which says g of t is equal to 5 cosine squared of pi t. So this has an outer function. Oh, what I'd like you to do is I'd like you to try to find these derivatives on your own, and then after you find them on your own, you can just maybe fast forward through the video and see if you can get the same answer as I do, and if you don't, then you can check to see what happened. So first of all, let's find g prime of t. The variable is t, so the 5 stays outside. We have an outer function of cosine, and the inner function, we have the outer function is x squared, The outer function is x squared, and the inner function is cosine of pi t. So what we really have here is another double chain rule, because when we find the derivative of the cosine of pi t, well, we have the outer function being cosine of pi t, and the inner function being pi times t. Remember, pi is just a constant. It would be like the cosine of 3t, for example. So when you do the derivative of the outer function, you get 2x to the first. Well, x is not our function, it's cosine of pi t. So taking the derivative of cosine squared, I'll just put this box in here. So we have 2 times the cosine of pi t raised up to the first power. And then we have to take the derivative of the cosine of pi t, says the chain rule. Well, now we've got to take the derivative of the cosine, which is negative sine of pi t. And then we have to take the derivative of the inner function, which is just pi. So I think that does it for us. We've taken the derivative of the outer. We've taken the derivative of the inner. And so now we can just clean this up. G prime of t is equal to 5 times 2 times pi, which is 10 pi. But we have a negative in there, so it's negative 10 pi times the cosine of pi t times the sine of pi t. And that's the end of that problem. The next example we're going to do is we're going to actually find an equation of the tangent line. At the given points. So we'll have our first example will be s of t, which looks like it's a position function. S of t is equal to the square root of t squared plus 2t plus 8, and we'll find that at point 2, 4. So we're going to find an equation of the tangent to this graph at this point 2, 4, which means we have to take a derivative, substitute t equals 2 as the slope, and then use the point slope formula on 2, 4. So I'm just going to rewrite s of t to be equal to t squared plus 2t plus 8 raised to the 1/2 power. The derivative of that is 1/2 times this to the negative 1/2. So it's 1 over 2 times the square root of t squared plus 2t plus 8. That would be 1/2 times that to the negative 1/2. And then the chain rule says you have to multiply this by the derivative of the inside, which is 2t plus 2, which will go in the numerator. And now what I have is a common factor here of 2. which will cancel out with this 2 in this denominator. So if I simplify this down, I'll just get t plus 1 all over the square root of t squared plus 2t plus 8. Now I want to evaluate this at t equals 2. So I'm going to find s prime of 2. So we have 2 plus 1 is 3, and in the denominator 2 squared is 4, plus 4 is 8, plus 8 is 16, which is 3/4. And now that is the slope for our point slope formula. So the tangent line is y minus y1 is equal to m times x minus x1. And there's the equation of the tangent line. Hopefully you're trying these on your own. The next one we're going to do is f of x is equal to 3 over x cubed minus 4, and I want to find that tangent line at -1, -3/5. So I'm going to rewrite this f of x function so I can take the derivative easier. So this 3 is a coefficient, and this x cubed minus 4 is actually raised to the -1st power. So I have an outer function of x to the -1 and an inner function of x cubed minus 4. So we can take the derivative of that. -1 times 3 is -3 times x cubed minus 4 to the -2 power. And then you have to multiply that by the derivative of the inside, which is 3x squared. So if we clean this up a little bit, this goes down to the denominator. So f prime of x is equal to -3 times 3 is -9x squared all over x cubed minus 4 squared. So now we want to find f prime of 1, or -1. So -9 times -1 squared is -9 all over -1 cubed is -1 minus 4 is -5. -5 squared is positive 25. So there's your slope, -9/25. And so the equation of the tangent line is y minus y1 is equal to m times x minus x1. So there you have that equation. The next one I'm going to do is here's our next example. Hopefully you saw all of that. The next one is y equals 1 over x plus the square root of the cosine of x. And I want to find the equation of that at pi over 2, comma 2 over pi. So I'm just going to rewrite this as y equals x to the -1 plus cosine of x to the 1/2 power, so I can take the derivative easier. Y prime is equal to -1 times x to the -2 plus 1/2 cosine of x to the -1/2 power. And then you have to multiply that by the derivative of cosine, which is negative sine of x, says the chain rule. And so to clean this up, y prime is equal to -1 over x squared. And it looks like we have a numerator that has a negative sign in it. So I'll do a minus instead of a plus negative. So minus sine of x in the numerator, and in the denominator we have a 2, and we have the square root of the cosine of x. So there's the derivative. And now I want to find y prime of pi over 2. Well, this would be -1 over pi squared over 4. And then that would just be -4 over pi squared minus the sine of pi over 2. Well, the sine of pi over 2 is 1, but in the denominator, the cosine of pi over 2 is 0. So right here you have an undefined fraction. So there is if there's a tangent to this graph, it would be vertical, or perhaps this graph could have a vertical asymptote at this particular point. So there is no tangent line defined for this. All right, and the last one I'm going to do is f of x is equal to the tangent squared of x, and we'll find that equation at point pi over 4 comma 1. So we have an outer function of x squared and an inner function of tan. So if we take the derivative of the outer function, it would be 2x to the first. So it would be 2 times the tangent of x to the first power. And then you have to take the derivative of the tangent, which is the secant squared of x. And there's your derivative of that. And now I'm going to find f prime of pi over 4. So that would be 2 times the tangent of pi over 4. Well, pi over 4 is 45 degrees, and the tangent of 45 is 1. So that's 2 times 1. The secant of pi over 4, well, the secant of pi over 4 is the square root of 2. But you have to square that because it's the secant squared. So what we have is 2 times 1 times 2, which is 4. So there's the slope. And then when you use the point slope formula, you have y minus y1 is equal to m times x minus x1. So there you go with the equation of that tangent line. And I'll probably do one more to wrap it up. Here's another example of a chain rule using a quotient rule. And I'm not going to ask you to find the derivative at any particular point, just find the first derivative of this function. Let's say y is equal to 3x minus 1 all over x squared plus 3, and this whole thing is squared. So you might want to shut the video off and see if you can find this derivative yourself and match it up with what I'm going to do. So here we have an outer function, which is x squared. We have an inner function, which is 3x minus 1 over x squared plus 3. So the derivative of the outer function is 2x to the first. So it's 2 times this whole inner function, 3x minus 1 over x squared plus 3, all raised to the first power. And then the chain rule says we have to multiply it by the derivative of this inner function. So let's take a look at this inner function. Well, this is a quotient itself, so we have to use the quotient rule on this. The derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. So let's get going with this. The derivative of the top is 3, and the bottom is x squared plus 3. And you subtract out from that the top times the derivative of the bottom, which is the derivative of the bottom is 2x and the top is 3x minus 1. And then you divide this whole thing by the bottom squared, which is x squared plus 3, quantity squared. And now what we have to do is we have to collect some like terms and simplify this down a little bit. So this 2 could actually go up to the numerator here, 2 times 3x minus 1. And in the denominator, we have an x squared plus 3, but we also have an x squared plus 3 in this denominator to the second power. And so if you multiply this denominator times this denominator, you get this whole x squared plus 3 raised to the third power. I'm going to have some other things going on here, so I'll make a great big long fraction bar. But in the denominator, there's nothing else that's going to move downstairs. So I'll just put this as x squared plus 3, all raised to the third power. Inside this parentheses, or inside this, in this numerator, we have 3x squared plus 9. We have minus 6x squared plus 2x. And so I think I'll clean this up a little bit. 3x squared minus 6x squared is negative 3x squared. We have a plus 2x and a plus 9. And this whole thing is all over x squared plus 3 raised to the third power. And that's about all we can do. This is simplified. I'm going to do one more example, or maybe two. Who knows? And yes, this will really be my last example. Let's do f of x is equal to x squared plus 3, but this whole x squared plus 3 is going to be raised to the fifth power, plus x, and the whole thing is going to be raised to the second power. So you have big parentheses on the outside here. And then you have x squared plus 3 raised up to the fifth power on the inside plus x. So now you have an outer function. Hopefully you see the outer function is x squared. Something is being squared. Well, what is being squared? The inner function, which is x squared plus 3 raised to the fifth plus x. So if you want to find f prime of x, the derivative of the outer is 2 times this whole thing raised to the first power. So that's x squared plus 3 raised up to the fifth power plus x raised up to the first. And then the chain rule says we have to multiply 2x times the derivative of the inner. Well, what's the derivative of the inner? Well, the derivative of the inner is 5 times x squared plus 3 to the fourth power. But then the chain rule says that you have to multiply that by 2x. So here we've got a outer function, which is x to the fifth, and we have an inner function, which is x squared plus 3. So to get the derivative of this term right here, it would be 5 times x squared plus 3 raised to the fourth power times the derivative of the inner function, and the derivative of x squared plus 3 is just 2x. And then we have to tack on the derivative of x, which is just 1. So there is f prime of x, the first step of it. Let's see, let's clean this up a little bit. F prime of x is equal to 2. This 2 is on the outside. Let's see, is there anything that we can do to clean this up? Oh, yep, the only thing we can do is multiply 5 times 2x right here. So we have 2 times x squared plus 3 raised to the fifth plus x, and 5 times 2x is 10x times x squared plus 3 raised up to the fourth power plus 1. And now I have a binomial times a binomial. So let's FOIL this. First, outer, inner, and last. So I'm going to drop the 2 down here. multiplying the first term, so we've got x squared plus 3 to the 5th times 10x times x squared plus 3 to the 4th. Well, if you multiply those first two terms together, you get 10x. X squared plus 3 to the 5th times x squared plus 3 to the 4th is x squared plus 3 to the 9th. That's my F. O, the outer terms, x squared plus 3 to the 5th times 1, which is x squared plus 3 to the 5th. That's O from FOIL. I, the inner function, x times 10x is 10x squared times x squared plus 3 raised up to the 4th. So there's my I. And then one more, L for last. X times 1 is x. So there's our final answer, 2 times 10x. And you can read this whole thing. And all I did was FOIL this out. If I needed to find another derivative of this function, it's a little bit easier after you get done foiling it out, because you could actually just take the derivative of each one of these terms, which would be easier than taking the derivative of this function, which is not foiled, because you need to use a product rule, and you'd probably have to go through several chain rules on top of that. So oftentimes, if you have two binomials multiplied together, the best thing to do would be to FOIL them out. And there was really no tricks to this, because when you have the same base, all I did was add the exponents. 5 plus 4 is 9, and the base was x squared plus 3, and tacking on a 10x. And then the other terms hopefully are pretty straightforward. So that is truly it, and I'll see you tomorrow.